Okay, so we're still working on this problem 71 on 702, and we know that dr over d theta, dr over d theta will be negative sine theta, and just let's find dy over dx, and we get negative sine square theta plus r cosine, so plus cosine theta plus cosine square theta divided by, again we have sine, negative sine times cosine, and minus, and I have to replace r by 1 plus cosine theta and distribute sine. So minus sine theta minus sine theta times cosine theta. So this is the derivative, and now we want to talk about horizontal tangents. Horizontal tangent, horizontal, is when the numerator is 0 for those values for which the denominator is not 0, as we had before in section 10.2. Good, so I'm going to set the numerator equal to 0. So I have cosine squared and cosine. I will replace this by 1 minus cosine squared theta. So I have an equation in cosine only. Good. So 1 distribute, negative 1 distributed, so negative 1 plus cosine squared plus another cosine squared, 2 cosine squared theta plus cosine theta equals 0. I will factor this because it's 2 cosine squared theta plus cosine theta minus 1 here. So we have 2 cosine theta minus 1 and then cosine theta plus 1. From here we go back to the unit circle. Okay, so this is my page 10 where I have cosine theta equals 1/2 or cosine theta equals negative 1. So let's find these values and see what we get. So from when cosine theta is 1/2, we know that the angle is pi over 3. So theta will be pi over 3 plus 2 pi k. And we know that cosine is negative 1. It's just one value, right? So theta will be pi plus 2 pi k. Remember, k is an integer. 0 plus or minus 1 plus or minus 2, and so on and so forth. Okay, let's continue with what we get at this point. So theta then could be, first of all, pi over 3. It could be pi. If so if pi 5, are we going over horizontal tangent for theta 1/2? So we have at 60 degrees or pi over 3, and we also have at another positive is pi minus pi over 3. Aha, right here, 5 pi over 3. And what else is there? Is there anything else? No, pi over 3 and then pi. So these are the quadrants in which cosine is positive for 1/2, pi over 3, and 5 pi over 3, and pi. This is it. So now let's determine the points. So remember, where is our curve? So r equals 1 plus cosine theta. Because the question is asking us to find the points. So the points will be, remember, r comma theta. 3 points with r comma theta. So theta, pi over 3, pi, and 5 pi over 3. So when theta is pi over 3, this is 1/2, and 1/2 plus 1 is 3/2. So we found 1 point. This is negative 1, so this will be 0. And for 5 pi over 3, again, is 1/2 and still 3/2. So we completed the horizontal tangents. Now, at all these points, we have to check whether the denominator is 0. So the denominator was, because they're, let me write it as is for now. So -2 sine theta cosine theta minus sine theta. So let's see what happens when we plug in pi over 3. Because if it is 0 at any of these points, then we need more clarification, more work for those points, or point or none. So for pi over 3, -2, the square root of 3 over 2, 1/2, and the square root of 3 over 2. Okay, so this is not 0. Let's see for pi. This is 0, this is 0, yes. So this is a question. This has a question mark. It cannot be vertical tangent and horizontal tangent, so we have to further investigate this point. Okay, now let's see here. It's going to be the same thing because sine, this will be positive, this will be 1/2, and this will be positive. Because sine is negative at 5 pi over 3. With minus in front will be positive again here, so this cannot be 0. So these points are okay. These are indeed the horizontal tangents. What we don't know is this one. We're going to have to further investigate. Maybe graph, we'll see in a moment. So now let's talk about the vertical tangents. So the vertical tangents happen when the denominator is 0, but the numerator is not. Okay, so vertical tangent. I'm going to set this equal to 0. Factor out sine. They're both negative, so I'm going to change them into positive. So sine theta 2 cosine theta plus 1 equals 0. Both of them were negative. I multiply both sides by -1, and I factor out sine. So here that we have two options. Well, multiple, but two big ones. Sine theta equals 0. And here we have two possibilities. Theta equals 0, theta equals pi. And for cosine, theta equals -1/2. So we're talking now about the second and the third quadrants, where we have a pi minus pi over 3. So pi minus pi over 3. So two angles here, theta and theta. So pi minus pi over 3 is 2 pi over 3. And pi plus pi over 3 is 4 pi over 3. So let's see what we get. So 0 pi, 2 pi over 3. So that's my page 11. Okay, so we're looking at 4 points this time. For 0, for pi, for 2 pi over 3, and for 4 pi over 3. Okay. So back to r equals 1 plus cosine theta. For theta being 0, this is 1 plus 1, which is 2. For 2 pi over 3, we know that this is -1/2. 1 minus 1/2 is 1/2. The same thing here, -1/2. 1 minus 1/2 is 1/2. And let's see for pi. For pi, we get 0. So now we're going to have to check the numerator to make sure. We already know that this is a problem. We have to check what's happening here. But we have to check the other three. The numerator is negative sine square theta plus cosine theta plus cosine square theta. If this is 0 for these, for 0, this is 0, but this is, yep, this is okay. For 2 pi over 3 and 4 pi over 3. So for 2 pi over 3, it doesn't matter because this is always positive. So this will be the square root of 3 over 2 squared. And this is negative 1/2, and this is plus 1/4. So 3 over 4 plus with minus. So negative 3 over 4 plus 1 over 4 minus 1/2. Is this 0? No, it's not 0. Okay, so now I have to check 4 pi over 3, which will be the same thing because this will be negative, this will be the same thing, and this will be the same thing because sine is squared. So these are okay. So last investigation, and the only thing that we still need to do, so the vertical tangents are at these 3 points guaranteed, the horizontal tangent at these 2 points guaranteed, but we don't know what happens at 0 comma pi. When r is 0 and the angle is pi. Okay, so calculator. Okay, so we go to y equals, clear, and we have 1 plus our 1 plus cosine theta, 1 plus cosine theta enclosed. And I want to graph r equals 0. See if this appears to be a vertical tangent or a horizontal tangent. And this will be red. So I have to zoom in. Okay. And it does not show. Okay, never mind. Why it does not show my r equals 0? Because it will show, it should still show the red that I was hoping to see. So r equals 0 and angle is pi. The tangent is horizontal. It's not vertical, but I can't show it to you. I can only find, for some reason, it doesn't show. If I see, 1 second, if I plug in pi, let's do that. If I have to change the auto into ask. Okay, so I want to plug in a pi and see what happens. So it is a horizontal tangent, not vertical. But how else I can show that? So this is a horizontal tangent, not vertical. So we have to remove it from here and accept it here. Yes. And how else I could show that? I could find a limit as theta approaches pi from dy, yes, dy over d theta over dx over d theta. Okay, which is from our calculations here. So we see that this is indeed 0. So that's what makes this point 0 comma pi be a point on the tangent line is horizontal. I was hoping to see that. I don't know why I didn't graph it, the calculator. I was just looking again. Just making sure that I didn't enter anything incorrectly. No, r was 0. Yep. Yep. Yep, it is a horizontal tangent. It cannot be vertical. We also see from the graph. So there is really no need to do anything else. Let me go back and zoom out. So as you see, it cannot be a vertical tangent here, obviously. I was hoping to show you even better, but obviously this is it's a horizontal tangent. It could not be vertical here. It would not be a tangent. So at that point. So obviously it's a horizontal tangent as you see it in this little corner or cusp. I hope this helps. Thank you.